Good morning, Honors Algebra 1. We're going to go ahead and move on in Chapter 8. Mrs. Latham and I decided to combine two sections, 8.5 and 8.6, because they more or less cover the same topic. This section is going to be expanding upon our concept of how to factor. Specifically, we're going to be factoring quadratic trinomials. Quadratic implying the highest degree term is going to be an exponent of 2. So highest degree is going to be 2, and trinomial implying that we're going to have 1, 2, 3 terms. And as a review, this polynomial here is technically written in standard form. The degrees are decreasing as you read it left to right. Okay, let's start with a bit of review. So in the past, we've learned how to determine what a GCF is and then factor that GCF out of the polynomial. So we're factoring a monomial out of a polynomial. Okay, so some of you definitely want to go back and review how to properly write a polynomial in factored form. A lot of you were just listing the GCF and then just stopping. That's not factoring. That's just listing the GCF. Factoring means that you're going to take the GCF and set it outside a set of parentheses, and to figure out what goes inside, you're going to divide all of these terms by the GCF, and those quotients go inside. It's kind of like the opposite of the distributive property. So distributive property, you're multiplying. Factoring, you're dividing. So we learned that a good strategy for figuring out what the GCF is to simply break down each term into its prime factors. So I can break 18 down into 2 times 9, or 2 times 3 times 3, and then I have x times x. I may want to make this font smaller because I'm going to need space here. Let's make it smaller. Let's do 14. Hopefully you guys can still see that. Let me know either in the assignment or email or even comment on this YouTube video if this is too small, and I won't make it this small again. Okay, 12x, I can break that down as 2 times 6, or 2 times 2 times 3. So 2 times 3 gives me the 6, and there's an x. And then negative 36, I can break that down as negative 2 times, let's see, that would be, what, 18? So 18, I can break down the same way I did up here, 2 times 3 times 3. And now I just determined what they all have in common. Well, they all have a 2 in common. Whoops. GCF. There we go. They all have a 2 in common. Okay. They all have a 3 in common. And let's actually highlight things as I go. So I've got a 2, a 2, a 2. I can't pull out another 2 because this one doesn't have it, but I have a 3, a 3. Whoops. Kind of a slow process, but this is kind of the foolproof way to do it. And then I can't pull another 3 out because this one doesn't have one. And I actually can't pull an x out because this term doesn't have it. So my GCF is just 6. Okay. Now I'm not done. This does not mean that I have factored. This is not factoring. This is just the GCF. To factor, I need to take the GCF and set it outside a set of parentheses. And what goes inside is what I get when I divide all of these terms by 6. 18x squared divided by 6, well, 18 divided by 6 is just going to be 3. And, whoops, I have an x squared. Remember, you're going to do format, text, superscript. I'm hoping that everybody knows how to do that at this point. So I am actually going to, for the sake of time, use keyboard shortcuts. This is going to be kind of a hefty section, so the video is probably going to be a little on the long side anyways. 12x divided by 6 is going to give me positive 2x, and then negative 36 divided by 6 is going to give me negative 6. This is factored form. This is my final answer, okay? I'm going to do the same thing for the other one. So I'm going to insert a text box so I don't have to keep doing anything weird with entering a new line or anything. And I'm going to do the same thing. I'm going to start with negative 2x to the power 5, and I'm going to break it down into its prime factors. Well, negative 2 is already prime, and I have 1, 2, 3, 4, 5 x's. I then will do the same thing with negative x cubed. Negative 8 can be broken down as negative 2 times 4, or 2 times 2. And then I have 1, 2, 3 x's. And I'm going to do the same thing with negative 4x squared. Negative 4 can be broken down as negative 2 times 2 times x times x. Notice how when I have a negative here, I only list the negative once. I think I saw a couple students listing that negative multiple times. You don't want to do that. If there's only the one negative, you should only have the one negative when you're breaking it down into its prime factors. Okay, so let's see what we have in common here. Well, we have a negative. That's common. So I definitely want a negative as part of my GCF. I have a 2. That's common. Remember, greatest common factor is what GCF stands for. So I definitely want a 2. I have more 2's in some of my other terms, but not in this one, so I can't pull out a second one. Let's see how many x's I can pull out. I have an x. I have an x. And I have an x. And I can actually pull out one more because this term has one more x. So I can pull out one more x from each term. They all have at least one more. That is my cat meowing. Sorry if you heard it. I'm not restarting this video. All right, so my GCF is negative 2x squared. So same thing like last time. This is not done. This is not factored. This is my greatest common factor, which I use to help me factor. My GCF is going to sit outside of a set of parentheses. And the terms that are inside the parentheses is what I get when I divide all of these original terms by the GCF. Okay, careful here. See how I'm pulling out a negative? If I divide all these negatives by a negative, it's going to leave me with positives inside. So I have to remember that everything inside is going to be positive. So I'm just going to ignore the negatives and divide everything else. 2x to the power 5 divided by 2x squared. Well, the coefficients are going to give me 1. And x to the power 5 divided by x squared, properties of exponents. I'm going to subtract those exponents and get an x cubed. Next term has to be positive because the negatives cancel. 8 divided by 2 is going to give me the 4. X cubed divided by x squared. If I subtract the exponents, that's just going to be an x. 4 divided by 2. Again, the negatives cancel to give me a positive. 4 divided by 2 gives me 2. And x squared divided by x squared gives me 1. Or x to the power 0, which ends up equaling 1, if you might recall. All right, this is my final answer. This is factored form, okay? So, as you can see, a huge clue to see that something is properly factored is that you see parentheses, right? That's kind of what we're going to be seeing in pretty much every problem that we do here. A few rules for factoring a quadratic trinomial. And a lot of these, as I just read through them, probably won't make sense. So I'm going to try to keep referring to them as I do examples. And I encourage you to rewatch this video as many times as you need to. And also either pause the screen or just look at this slide in the PDF notes as you try to factor your trinomials, okay? So this is sometimes called the AC method. I have been taught in the past, it's been called the split the middle method is what it was called when I was taught this, but it's typically in your textbook and other teachers will probably call it the AC method. Step 1 when you are looking at a trinomial in standard form, you find the factors of a, c, so a times c, you're going to multiply them, a times c, you're going to multiply those together and it's going to give you a number, and you're going to find factors, meaning two numbers that multiply to give you that product, that have a sum of b. So then what you're going to do is you're going to take those two factors and you're going to break this middle term into those two factors so that they sum to give you the original b term, but still multiply to give you the value of AC. Next, what you're going to do, after you do step 2, you should have not a 3-term polynomial, but a 4-term polynomial, because you're going to break this up into 2 terms. Then what you're going to do is you're going to factor a GCF, just like we did here on this slide. You're going to factor the GCF from the first 2 terms, and you're going to factor a GCF out of the last 2 terms. If you do step 3 correctly, okay? If you do this step correctly, you should see that after you have factored that GCF out, your binomial, which is what it's going to be a binomial, 2 terms, your binomial in the parentheses for those 2 groups are going to match, and you're going to factor that common binomial out, okay? And then that's going to be one of your binomials, the common binomial. The second binomial is going to be what those 2 binomials were touching, okay? A lot of that probably did not make sense as I explained it, but I'm going to try my best to refer to those steps as I do examples. Okay, so step 1, find factors of AC that have a sum of b. Well, we have to find the AC value, don't we? The AC value here, A is 1. I may just type that in real quick. Remember, if there's nothing in front of that, it's a 1. A is 1, C is 15. So my AC value here is going to be 1 times 15. Okay, so 1 times 15. I may want to just move this and type that in. So AC equals 15. So I'm just going to put that there so I remember. I've included a little table here so that way I can kind of systematically try to find the factors of AC that sum to B, because I might not get it for my first try. It's kind of like a guess and check. So 15 is not that bad of a number. There's not a lot of factors. There's not a lot of numbers that multiply to 15. I could do 1 and 15, right? 1 times 15 gives me 15, but the question is, does that sum to the b value? Let's see. 1 plus 15 gives me 16, which is not what I want. I want my sum to equal 8. So I have to keep going here, okay? Well, what are some other factors of 15? Well, I could try 3 and 5. 3 times 5 gives me 15. Question is, when I add 3 plus 5, does that give me 8? It does. So that's actually what I want to use. Here are my winners here. Right here. These are my winners. I want to highlight them. I want to use these. So, whoops. What I need to do, what step 2 says, is you break that bx term, that middle term, okay? I break this middle term into 2 terms so that way I still get 8x when I add them back together again. Basically, you're going to rewrite 8x using these 2 factors. So it's going to be 1x squared. That doesn't change. Keep hitting the wrong key there. And instead of 8x, I'm going to write it as plus 3x. So this is going to be one of my terms. And then plus 5x. That's going to be my other term. So notice I'm rewriting it so that way these 2 factors add to give me the 8x back. Because we don't want to change the polynomial. We don't want it to equal anything different. We just want to rewrite it. And then the plus 15 comes down for the right. I'll minimize it a little so we can see it. Okay. You with me, Honors Algebra 1? This is not easy stuff. All right, so step 3, factor out a greatest common factor from the first 2 terms and factor out a greatest common factor from the last 2 terms. Well, if I think about, sorry, my cat's meowing, sorry. If I think about what's common between these first two terms, I can definitely pull out an x, and that's pretty much it, right? 1 and 3 have nothing more in common other than a 1. So all I can pull out is an x. And remember, when you factor, you're going to divide these two terms by the GCF, and those quotients go inside. X squared divided by x just gives me x. 3x divided by x just gives me 3. Okay, I'm going to do the same thing over here. I can pull out just a 5, and when I do this, I'm going to write the sign of the number that I'm pulling out. I can factor out as my GCF a positive 5. I can't stress the symbol enough here. If you don't put this here, you're not going to, you might forget, I should say, you might forget what symbol to put in your final answer. So please, if it's a positive, put a positive. It's a minus, put a minus. But I can factor as my GCF a positive 5. And in my parentheses, what I get when I divide, 5x divided by 5 is just x, and 15 divided by x is positive 3. So you might recall, I mentioned when you do step 3, those two binomials in the parentheses that you're left with should match. If they don't, you've done something wrong, okay? You need two matching binomials. You need a common. Common means they're the same. They match. Common binomials is what you need here, okay? When you get to this step and you have two common binomials, you're going to write your final answer in factored form. And what it's going to look like is a set of two binomials that are touching, being multiplied together, okay? One of those binomials is going to be the common binomial that you see, and then you're going to immediately open another set of parentheses, so no plus or minus sign here, okay? No plus or minus. These are two binomials being multiplied. The other binomial is going to contain the things that those common binomials were touching. Okay, so I'm going to have an x and then a positive 5. Here is my final answer. Okay, this is factored form for a quadratic trinomial. So to recap, what we did is we found the AC value by multiplying a and c. We then found the factors of a and c that would add to give us the b term. We broke that b term up into those two factors. We factored a GCF out of the first two, factored a GCF out of the second two, and then we wrote our final factored form. One of the binomials is the common binomial, and then the second binomial is the things that the common binomial was touching. And those two binomials are being multiplied. There is no plus or minus here. Please don't put a plus or minus here. If you put a plus or minus here, it's not going to be correct. Let's do another one. I've got a lot of examples to guide you through today. So my AC value here is going to be 1 times 24. I'm going to move this table here. See if I can do that easily. So let's start with some factors of 24. Now notice here, my B value is negative. Well, think about it. If I want two numbers that are going to add to give me a negative, then I've got two choices. Either those two numbers can be negative, so that when I add them, they give me a negative, or they can be different signs. So when I add them, the quote-unquote larger sign wins, and I get a negative answer, okay? But think about it. If those two numbers have to multiply to give me a positive, then they can't have different signs, because when I multiply them, I'm going to get a negative. So both of my answers here have to be negative. So this is what I like to refer to as the AC is positive, BX is negative case. Both of your factors have to be negative when this is the case. So both have to be negative, regardless of what number I use here. So let's start trying some factors. Well, I could try negative 1 and negative 24. That would give me positive 24, but if I add them, it's going to give me negative 25. So that's not going to work. I could try negative 2 and negative 12. That'll give me positive 24. But if I add them, it's going to give me negative 14. So that's not going to work either. I could try -3 and -8. That'll give me -24. 8, 9, 10, 11, if I add them, will in fact give me -11. So that's our winner. So I'm going to break that bx term up into -3x and -8x. And the plus 24 comes down for the ride. So notice everything else stays the same. This quadratic term stays the same. This constant stays the same. The only thing you're changing is this. Okay, this bx term splits into 2. This is why it's sometimes called split the middle, because you're splitting that middle term. All right, next step, factor a GCF out of the first two. All I can pull out is an x. That's the only thing they have in common. If I divide these two, I'm going to be left with x minus 3. And now I have to factor a GCF out of these two. Notice how the leading term is negative. When that's the case, I want to factor a negative out. I can factor an 8 out. They both have an 8 in common. I can't factor an x because this one doesn't have one. This is going to leave me with a positive x and a -3. So as you can see, I know I'm on the right track because I've got a binomial that matches here. That's going to be one of my binomials in my answer. The second binomial, which touches, is going to contain the other two terms, which they were touching. So an x and a -8. See why it's so important to put the sign here? You need to know what sign to put in between these two terms. This is in factored form. This is my final answer. Let's try another. AC here, 1 times -15. I have to include that sign. It's going to give me -15. I'm going to move my table again. All right. So my AC is negative. So remember, you're trying to find factors that'll multiply to give you -15. Well, I can't make both factors negative. That'll give me a positive when I multiply them. So one of my factors has to be negative and the other has to be positive. Okay? So you need to think strategically about your signs here. It's kind of like solving a puzzle. Factoring a trinomial like this is like solving a puzzle. If the AC value is negative, but your B term is positive, make the larger factor the positive. Okay, so I'm going to make my larger factor, regardless of what that factor is. If it's the larger one, I make that one the positive, because think about it. If you add two numbers that have different signs and the quote-unquote larger one, I'm putting it in quotes because it's, you know, positives are always larger. Really, it's the one furthest from 0, but if the larger number's positive, then that's the sign that wins when you add them together, and we want that. We want the sum to be positive. Okay, so I could try 1 and 15. This is the smaller one, so I make that one the negative. That'll give me the -15 as a product, but 14 as a sum, so that doesn't work. I could try 3 and 5, and I'll make the smaller one the negative. That'll give me -15 when I multiply, and it'll definitely give me +2 when I add. So here's the winner. I'm going to highlight that so we can see it. So I'm going to break bx into a -3x and a +5. All you're doing is you're just taking these and you're replacing this b term with these two factors and making sure that they have x's. And then the -15 comes down for the ride. Same thing as last time. I'm going to factor a GCF out of these first two terms. That's going to leave me with an x minus 3. I can factor a +5 out of the last two terms. That's going to leave me with an x minus 3. I have a common binomial of x minus 3. And then the second binomial, which is touching, I simply put the two things that common binomial was touching, which is x plus 5. Here is my final answer, and it is in factored form. Okay, only a couple more slides to go. I'm going to try and go through these as quickly as I can. Okay, so here my AC value, now I need to make sure that I'm multiplying correctly. My A is 6, my C is 5, AC is 30. So I need factors that multiply to give me positive 30 and add to give me positive 13. So everything's positive here. When that's the case, all of your factors will be positive. There's not too many factors of 30. I can start with 1 and 30. That'll give me the product of 30, but a sum of 31. That is not what I want. I could do 2 and 15. 2 times 15 is 30. 15 plus 2, though, gives me 17. Still not what I want. I can try 3 and 10. That'll give me 30 when I multiply, and it does, in fact, give me 13 when I add. And do you notice how I'm slowly increasing one column when I do this? I try to pick my factors systematically like this, and sometimes you might even be able to look at this number and immediately know what factors will work for both criteria. That comes with practice. I'm just kind of going through all of them to show you. So I'm going to take these two here, which are my winners, and I break the B term up into those two terms. Positive 3x, positive 10x, that plus 5 comes down for the ride. I can factor a 3 for my coefficients for the first two, and an x, so I can take out a 3x. If I divide, my first quotient is going to leave me with a 2x, and the second quotient is just going to be 1, not 0. 3x divided by 3x is 1. It's kind of like how 4 divided by 4 equals 1, not 0. I can take out a 5 for my coefficient for the next two terms, so it's going to be a positive 5, and I can't take out an x. I'm going to be left with 2x plus 5 divided by 5 gives me 1. And I can see that I'm doing it correctly because I've got a binomial that matches. That's going to be one of my binomials in my final answer. And the second binomial, which touches this one, is going to contain the things the common binomial was touching, 3x and positive 5. Here's my final answer. Let's try another one. My AC value here, I'm going to get 3 times negative 15. I'm going to double check my mental math with a calculator. I think it's 75. Nope, 45. Good thing I double checked, huh? It's late in the day for me right now. It is 7:30 on a Sunday, and I'm still working. All right, so negative 45 is my AC value. So again, I know that my signs have to be different because that's the only way I can get a negative product. And if my B term is positive, I want to make sure that the larger of the two is positive. Okay, basically whatever sign your B value is, if your AC value is negative, make the larger factor match whatever sign the B term is. Okay, so I can start with negative 1 and 45, but that's going to give me a sum of 44. I can do negative 3 and 15. That is going to give me 13, 15, 14, 13, 12. I'm tired. 12, yes. So that's not going to work either. I need a sum of 4. Shush, Sue. My cat is meowing. She's probably hungry. Let's see. I can't do 4. Oh, I could try 5. Negative 5 and 9. So negative 5 plus 9 gives me 4. Haha, we found them. These are our magical numbers that work. Okay, so I'm going to break down that middle term as a negative 5x and a positive 9x, and then the minus 15 comes down for the ride. All right, we're in the home stretch. I can't take out a coefficient other than 1, but I can take out an x. That's going to leave me with a 3x and a negative 5. I can take out, both of these have a 3 in common, a positive 3, and that's going to leave me with a 3x and a minus 5. My binomials match. 3x minus 5 is going to be one of them, and the second binomial will contain what that common binomial was touching, which was x and then plus 3. Here's my final answer. I'm hoping that you guys are catching on at this point. Okay, AC value here, 4 times negative 6 is negative 24. And my B value is negative here. So when this is the case, I still want different signs for my factors because I need a negative product, but now I want the larger number to have the negative, okay? So I could try 1 and negative 24. That's going to give me a sum of negative 23. That's not going to work. I could try 2 and negative 12. That's going to give me a sum of negative 10. That's not going to work. I could try factors of 3 and negative 8. That's going to give me a sum of negative 5 when I add positive 3 with negative 8. So here are our winners. Here are our winners. I'm going to break this up as a positive 3x and a negative 8x. Minus 6 comes down for the ride. I can factor out an x from these first two. I can't factor out a coefficient because 4 and 3 don't have anything in common other than 1. So I'm still going to have a 4x plus 3 because all of the x's came out of that second one. And notice here, my leading term's negative, which means that whatever I pull out, it's got to be a negative. I can take out a 2. They both have a 2 in common. And then that's going to give me a positive 4x and then a positive 3. Negative 6 divided by negative 2 gives me a positive. I have matching binomials, so my common binomial will be one of my two binomials. The second one will be what that common binomial was touching, so x minus 2. And again, there's no plus or minus when you get to this last step. These binomials are touching. And just to show you how you could check, we actually learned how to multiply two binomials together. You could FOIL this out or use the table method to see if it matches the original polynomial. If it doesn't, you factored incorrectly or multiplied incorrectly. All right. AC value here, 8 times positive 3 gives me 24. So I need a positive product, but a negative sum. When this is the case, both of your factors have to be negative. 2 negatives multiply to give you a positive, 2 negatives add to still give you a negative. I could try 1 and 24. That's just going to give me 25 as a sum. Oh, both have to be negative. That's going to give me negative 25, which is not what I want. I want negative 14. I could try negative 2 and negative 12. Aha, if I add these two, that gives me negative 14. I'm going to break this middle term up. I'm going to split the middle. I'm going to have a negative 2x minus 12x plus 3 comes down for the ride. I can factor out a 2, and I'm going to factor out a positive because even though this one's negative, this one's positive. Leading term is positive. Oh, and I can factor out an x. That's going to leave me with 4x and then a minus 1. Leading term is negative here, so I know whatever I take out, it's got to be negative. And then I can factor a 3 out of both of these. That's going to leave me with 4x, negative 12 divided by negative 3 is positive 4. And then 3x divided by negative 3, or excuse me, 3 divided by negative 3 gives me a negative 1. These two binomials match, so that's part of my answer. The second binomial that it's touching will be the terms the common binomial was touching. So 2x and then minus 3. Here's my final answer. This was the final example, thank goodness. So go ahead, give the online learning slides a try. I know I kind of went through these quickly, but it was a lot. If you have questions, please reach out. And remember, if you get stuff wrong, I'm going to leave feedback. You can go back and correct it and then resubmit it to get a higher grade. Okay, I especially encourage you to do that with this stuff because it's not easy material. Okay, don't forget to click turn in when you are finished and ready for me to grade it. Take care, guys. Have a good one.